This is Ham College, episode 126, for July 3rd, 2025. Ham College is brought to you by ICOM. As the days get longer and the bands heat up, make sure you're ready with a radio that works as hard as you do. So kick back and enjoy the breeze and make those QSOs with ease. Hi, welcome to another episode of Ham College. I'm Professor Thomas.
I'm Dean Martin.
And it's the 4th of July tomorrow. This is the 3rd of July.
Yep. This is actually a Thursday, too, not Friday as usual.
Right. You had a gig booked for the 4th, so...
Yeah.
Different topic tonight. I think it's a little more interesting, or a little more fun, maybe.
Yeah, a little more practical, too.
Yeah. What did we talk about last month?
Well, the best I recall, we talked about propagation modes. Sporadic E, meteor scatter, auroral propagation, tropospheric ducting, F region skip, line of sight, and radio horizon, last but not least.
Okay.
That's best I recall, unless you think of something else.
No, I think that's pretty close.
Okay.
That's to my recollection. Tonight we're going to talk about station setup. Connecting a microphone, a power supply, a computer, digital equipment, an SWR meter, bonding, and mobile radio installations. So if you're a new ham or about to get licensed, these are all fun things right here.
Yeah, it's very, very, very useful information, too.
Yeah.
Something pretty much every one of us will do all of it at some point. All right, you ready?
Yeah.
Which of the following is an appropriate power supply rating for a typical 50-watt output mobile FM transceiver? A, 24.0 volts at 4 amperes.
B, 13.8 volts at 4 amperes.
C, 24 volts at 12 amperes.
Or D, 13.8 volts at 12 amperes. Which of the following is an appropriate power supply rating for a typical 50-watt output mobile FM transceiver? 24 volts, we know it's not that. It's going to be run in a car which has a 12-volt battery. That's typically going to be more than 12 volts when your alternator's running. So we can rule out A and C because we know it's not 24 volts. So it's either going to be B or D, because those are 13.8 volts, and that's probably what you'd have in a typical vehicle. That's what all our 2-meter rigs, FM rigs, are rated at. Amperes. So it's either going to be B, 4 amps, or D, 12 amps. I just happen to know that our 2-meter radios, FM radios, they're going to require 12 amps, not 4 amps. If you remember back to the old CB radio days, they used to sell 4 amp power supplies that you could run your CB radio off of.
Yep.
And of course, the CBs were AM, so that takes a little more power than an FM transceiver because you're swinging modulation as well. But if a CB, which was down around 5 watts or thereabouts, took 4 amps, 50 watts on FM, it's going to be at least 12.
Yeah.
So, or thereabouts. I'm going to go with D. Do you concur?
I do, finally.
Okay, well, most everybody is saying D, and it is.
All right. Here. Give you that because we made it through it.
Let's see if that makes sense now.
Okay.
I just happened to have brought a calculator with me tonight. Power equals current times voltage. P equal I times E. The current, we said, was 12 amps. And the voltage was 13.8. 165.6 watts. That's not 50 watts, is it?
Nope.
That's current times voltage. That's what the power consumption would be for 13.8 volts at 12 amps. Before we go any further on that, let's try the other one. 13.8 volts times 4 amps, 55.2. That's closer to 50 watts, isn't it?
Yeah.
But do we know that's not right? Nothing's 100% efficient. So a 50 watt radio transmitter is going to consume a lot more than 50 watts. You get 50 watts out of it, but you're going to lose a lot of that power in heat, and then everything else that the radio is drawing. But the final stage is, I didn't look it up to see what typical efficiency is on a 50 watt rig, but it's nowhere near 100%, and apparently it's way less than that. If we look at a typical rig here, the IC2730B, if you look under the specifications there, what does the...
There it is.
13 amps.
13 amps.
Okay. And that's from the manufacturer. 13 amps. And the answer was 12 here, of course. So...
That's pretty close.
Pretty
It
close.
says typical.
Yeah. I actually looked up some other brand radios, too.
Mm-hmm.
I looked up a comparable Yaesu radio, and it was drawing 12 or 13 amps. So that's pretty typical. 12 amps, that's just enough to do the job, apparently.
Yeah, if you're going to buy a power supply to run your mobile rig in, you want some headroom. You don't want to, max it out.
20 amps is probably what you want to
Yeah,
get.
that's what I used for years. Actually, that's probably what I was still using.
Mm-hmm.
Still got my original 20 amp Estron with the meters on it.
I do too. Which of the following should be considered when selecting an accessory SWR meter? Is it A, the frequency and power level at which the measurements will be made?
Or B, the distance that the meter will be located from the antenna?
C, the type of modulation being used at the station?
Or D, all these choices are correct. Which of the following should be considered when selecting an accessory SWR meter? Type of modulations. No, so I don't think the modulation is going to matter, so D is not going to be right either. So we're down to B or A. And distance would be from the antenna is not going to really matter either. I guess we're not really, but so it's going to be A, the frequency and the power level at which the measurements will be made. I don't think you want to put a little tiny little SWR meter on something and run a KW through it for a legal limit.
No, and you wouldn't run 2 meters through an HF meter either.
Yeah, right.
A.
Fonzie.
Yeah, I'll agree with you along with everyone in the chat room there. Okay.
All right.
Let's just talk about B there. That's not the right answer, of course. But where would be the best place to put an SWR meter in your setup?
On the transmit line out of the rig between the antenna and the radio, but probably closest to the radio.
Yep.
Closest you can get it to it.
Because that's who's really going to care if you're hitting them with a high SWR.
Why are short, heavy gauge wires used for a transceiver's DC power connection? A, to minimize voltage drop when transmitting.
B, to provide a good counterpoise for the antenna.
C, to avoid RF interference.
Or D, all of these choices are correct. Well, let me read that question again. Why are short, heavy gauge wires used for a transceiver's DC power connection? Well, it's not D. We'll rule that out. C, to avoid RF interference. No. Gauge of your power cable is not really going to affect that. B, to provide a good counterpoise for the antenna. Well, your ground wires or your power wires not going to act as a counterpoise. Even if it did, the gauge of it wouldn't have any effects. All we're left with is A, to minimize voltage drop when transmitting. And that's the only logical choice, and I think most people should be able to figure that one out right there. But let's just see if that is the right answer. People in the chat room, they're all saying A, which is what I'm saying.
Okay. That's one that seems to make sense to me as well.
And it is. And it's pretty easy to figure out, because if you've got a little skinny wire going to your transmitter or your rig, and you are trying to run 50 watts, that little tiny wire is going to get really hot.
Yeah, like a heater.
Yep. What happens when a wire gets hot? Well, the resistance on it increases. So it's going to act as a voltage divider. In other words, the radio itself is going to be drawing voltage. But if you've got a wire in there that's too small and it's getting hot, the resistance increases on it, so it's going to drop some of your voltage before it ever gets to the radio. If you use a bigger wire, then the wire's not going to heat up when you transmit, hopefully, if you use a big enough gauge. And so there's not going to be much resistance in it. Bigger gauge conductor has less resistance. Smaller gauge, your wire starts having resistance on it. That will actually have an effect.
Mm-hmm. Oh yeah, if you won't get your full 50 watts on a 50-watt rig. Good chance if you use too small a wire.
Yep. How are the transceiver audio input and output connected and a station configured to operate FT8? A, the computer running a terminal program. Let me start over on that one. A, to a computer running a terminal program and connected to a terminal node controller unit.
B, to the audio input and output of a computer running WSJTX software.
C, to an FT8 conversion unit, a keyboard, and a computer monitor.
Or D, to a computer connected to the ft8converter.com website. I'm going to have to jot that website down and see if that exists, but that's not the answer. D is not the answer. C is not the answer. The FT8 conversion unit. I don't even know what that is. B, to the audio input and output of a computer running WSJTX software. That's going to be it. But let's look at A again just to be sure. A, to a computer running a terminal program connected to a terminal node. Now you don't need a T and C, so it's going to be B. To the audio input and output of a computer running WSJTX software. That's my final answer.
I'm going to agree with you. Everyone in the chat room does as well. There you go. 4th of July fireworks there.
Yeah.
And I know you're correct because I did it this past weekend during field day. I ran FT8.
I did. I set mine up too. Well, I had a problem, but yeah, I tried.
But did you ever run any after that?
No. I could copy, but I couldn't. For some reason, nobody was hearing me. I don't know what the deal was.
Yeah.
So I need to make sure my audio output level's set right. I think that's pretty critical.
Oh, yeah.
So I got to figure out how to test that. I don't remember.
Okay.
Probably my issue. Where should an RF power meter be installed? A, in the feed line between the transmitter and the antenna.
B, at the power supply output.
C, in parallel with the push-to-talk line and the antenna.
D, in the power supply cable as close as possible to the radio. Most people should probably be able to figure this one out right here. It's A, and that's what the chat room's saying over there. Where should an RF power meter be installed? There's the first fireworks.
Oh, wow.
Thought it was raining. A, in the feed line between the transmitter and the antenna. That's the only logical choice out of all those. You don't put it in the power supply line. I don't think it'd be possible to connect it in parallel with the push-to-talk button and the antenna, since those two are not connected. Yeah, and D, not in the power supply cable. If you're measuring RF power, you're measuring the transmitted signal. It'd have to go between the transmitter and the antenna.
Hats off to whoever came up with C.
Yes.
That took some imagination there.
Yeah. That's going to separate the crowd there.
Impressive.
What signals are used in a computer radio interface for digital mode operation? A, receive and transmit mode, status, and location.
B, antenna and RF power.
C, receive audio, transmit audio, and transmitter key.
Or D, NMEA GPS location and DC. D, NMEA GPS location and DC power. Wow, that was tough. What signals are used in the computer radio interface for digital mode operation? Receive, transmit mode, status, and location. Transmit mode. No, it's not A. B, antenna and RF power. That doesn't go in the interface. It goes in the radio or from the radio. Receive audio, transmit audio, transmitter key, and that's going to be it right there. Or D, NMEA GPS location. No. It's going to be C.
That's what
Receive
they're all
audio,
saying.
transmit audio, and transmitter key.
There you go. Oh, and I just noticed in the chat room, in that last question, we were talking about being in parallel with the push-to-talk button and the antenna, being the wrong answer. Clearly, it needs to be perpendicular. No, it's not right either, of course.
That's pretty good, though.
It is. And that is half of tonight's questions.
Wow.
Came quick, didn't it?
It did. When you're having a good time, it just blows by.
Yep. What do you say we take a quick break?
Fun, Sun, and QSO. Wherever you go, keep the fun going with one of ICOM's go-to rigs. As the days get longer and the bands heat up, make sure you're ready with a radio that works as hard as you do. So kick back and enjoy the breeze and make those QSOs with ease. Remote ready, contest capable, and built for serious signal, step into the future of amateur radio with ICOM's powerhouse trio. The IC7760 HF digital transceiver, the IC-PW2 1 kilowatt HF 50 MHz linear amplifier, and the all-new RC7760 remote controller. Designed to work in perfect harmony, this system offers full remote operation, high output power, and seamless integration across the bands. The RC7760 remote controller serves as an extra control head, and up to 5 can be registered to the RF deck, though only one can be active at a time. For wireless connectivity, simply connect a commercially available Wi-Fi access point via the LAN port. Whether you're working from the shack, the field, or a remote site, you'll experience crystal clear audio, digital precision, and amplifier-grade power, all from a single unified interface. It's the ideal setup for contesters, MCOM operators, and high-demand users who expect more from their gear. The IC7300 combines intuitive touchscreen control, real-time spectrum display, and superior signal purity into one compact rig. Built for satellite, EME, and weak signal enthusiasts, the IC9700 combines all-mode operation on VHF, UHF, and 1.2 GHz. The IC2730A now features a high-contrast black display. It offers everything operators love: true dual-band operation, independent control knobs, and optional Bluetooth compatibility for hands-free operation. The IC718 is a favorite among new hams and portable operators, offering simple operation, rugged construction, and clean audio with DSP filtering. For more information about all of ICOM's great amateur radios, visit icomamerica.com/amateur today.
How about we give away this cool ICOM Ham Crew t-shirt? Or one like it.
Looks nice.
Looks just as good on the back as it does on the front.
And maybe Jesse will stuff a little extra stuff in the box, too.
I bet he will. He usually does.
Yeah. So if you'd like to win that, how could you do it?
Well, the qualifications are pretty steep, so not everybody can get it. You got to have a name and an email address.
You
That's
don't
all.
need a license?
You don't need a license. We're here to help people get licensed. So that wouldn't make sense to have that as a qualification.
Good point.
So send your email to hamcollege@AmateurLogic.TV. If you want to put a little note in there, that's cool, but you don't really have to put anything in there. Just send the email.
Okay. We just did a random drawing like just seconds before now.
Your name would be good to put in there, though.
Well, he does have a name,
Perfect. He's overqualified.
and it's Vance Smith,
Oh, cool. Awesome.
Yeah,
Congratulations, Vance.
and he actually had a message in there.
What's he saying?
He said, "I love your Ham College shows. I'm trying to retire, so this will be added to my list of TV shows, and the Western will go to the bottom of my list. Thank you for all you do for ham radio."
You're welcome.
Okay.
It's our
Thanks,
pleasure.
Vance.
Li-
Glad you
literally, it's
enjoy
our
it.
pleasure.
Yeah. I mean, if we're beating out the Westerns now, that's pretty,
I know, right?
yeah.
It's on up there.
Yep. Maybe we can get us a couple of cowboy hats. Congratulations, Vance. Icon will be getting this right out to you. They'll
Yeah.
be in touch, though, to get your details for shipping.
We'll be
on.
looking for you at the Ham Fest with your shirt on.
Yep. You'll be one of the best dressed hams there.
Which of the following connections is made between a computer and a transceiver to use computer software when operating digital modes? A. Computer line out to transceiver push to talk.
B. Computer line in to transceiver push to talk.
C. Computer line in to transceiver speaker connection.
Or D. Computer line out to transceiver speaker connection. Which of the following connections is made between a computer and a transceiver to use computer software when operating digital modes? Well, let's rule out a few of these first. You do not hook either the line in or the line out of your computer to the push to talk button. That would not be a good idea. So we're going to knock A and B right out. So that leaves us with two other choices here. Let's see. C, computer line in to the transceiver speaker connection. Or D, computer line out to the transmitter speaker connection. It's C.
Why is it C?
Why is it C? Well, I can explain that. Let's see if I am right. What's the chat room saying? Yeah, it does seem kind of obvious, doesn't it? But some people,
But some people
you
may
haven't
not
done
know.
it. Yeah. It's if you're not thinking about it right, you'll be thinking about it wrong. And
No truer words have ever been said on this show.
yeah, that sums
That's
it up.
very
That
profound.
sums up all the years. It is C.
Yeah, it is C. And
And-
I knew it was C.
And
But
you
why
ask,
is it C?
why is it C? Here's the reason why right here.
You just happen to have a handy diagram.
Left-hand side, we got a computer. On the right-hand side, we got a radio. This is how you hook it up. The line in on the computer, or it could be the microphone in on the computer in the case of a laptop, is connected from the speaker out, or the radio might have a line out. That gets the audio that's being received into the computer so that it can decode it. You're going to want to transmit something back, so the line out or speaker out from the computer goes to the microphone in, or if the radio's got it, the line in. That's how it goes. In goes to out.
It's a big circle.
Or out goes to in. But in doesn't go to in and out doesn't go to out. If you're mixing like speaker out level going into microphone in on a computer, you might need to do a little matching or something there so you don't overload the microphone in on the computer. And conversely, if you're coming out of the speaker output on the computer going into a microphone input on the radio, you may need to pat it down a little bit to keep from overloading the microphone input on the transmitter.
Why would you have to do that?
Why would you have to do that? Because the signal could get so distorted that...
Because line level and mic levels are different?
They are. And speaker level too. You know, microphone is a tiny little signal. It's not very big at all. A speaker level coming out of a computer or radios, that's got a little power behind it. Little voltage, much more than a microphone, so it'd be easy to overload that microphone input.
Good explanation. Thank you.
Okay. I have a question for you.
Okay.
Which of the following conductors is preferable for bonding at RF? A copper braid removed from coaxial cable.
B, steel wire.
C, twisted pair cable.
Or D, flat copper strap. Which of the following conductors is preferred for bonding at RF? A, copper braid removed from coaxial cable. B, steel wire. Twisted pair cable. I think the more surface you got, the better off you're going to be. So I'm going to go with the D, flat copper strap.
Okay. That's what the chat room is saying. I agree with you. That is correct. And I happen to have some flat copper strap over here.
Cool.
At least I think it's hanging over there. That's where it's supposed to be. And that's the best.
What are they referring to as bonding?
Bonding. That's like you want to connect the ground on a radio to a ground on your antenna or your vehicle or whatever. For RF, we're talking about basically what's coming out of the antenna or going into it. So if you're connecting, say, you need to connect the ground of the antenna to the ground of your station, flat copper strap is going to be the best. Mm-hmm. What if you didn't have any flat copper strap? Are you just out of luck?
No.
Could you use one of those other three? And if so, which one would you use?
I would probably use the copper braid removed from the coax cable.
I believe that's what I would use too.
More surface area there.
Yep.
For the skin effect.
It's all about the skin.
Give you some skin, bro. I hadn't heard that in years and years. That was like a 70s slang.
Yeah, where'd that even come from?
I have no idea.
Yeah.
Throwback. Yep, I think that would be the next choice I would use out of the selection up there. Yeah. I think I'd stay away from the steel wire.
I would, and the twisted pair cable wouldn't be a good choice. But if that's all you got and you need to do some bonding,
roll with it.
Yep.
Till you get better.
Use what you got, but ultimately flat copper strap is better. If you go snooping around a radio station, that's what you're going to find.
Flat copper strap?
Yep.
I actually bought some little grounding straps. They actually look like copper braid removed from coax cable, flattened out with the connectors pressed on them.
I have some too. but it's not the right thing to use. I
Yeah.
typically use that for grounding my radio, say, to the vehicle chassis.
Yeah. Yeah, that's actually what I bought them for.
Yeah.
All right, here's a long one for you. You ready?
Yes.
How can you determine the length of time that equipment can be powered from a battery? A. Divide the watt-hour rating of the battery by the peak power consumption of the equipment.
D. Divide the battery ampere hour rating by the average current draw of the equipment.
C. Multiply the watts per hour consumed by the equipment by the battery power rating.
Or D. Multiply the square of the current rating of the battery by the input resistance of the equipment. How can you best determine the length of time that equipment can be powered from a battery? Let's look at D there. Multiply the square of the current rating of the battery by the input resistance of the equipment. That's a creative wrong answer there. It's not that. C. Multiply the watts per hour consumed by the equipment by the battery power rating. That would be that would put you way off from being correct. It's either going to be A or B. And A, divide the watt hour rating of the battery by the peak power consumption of the equipment. That's not really right, because the peak power consumption of the equipment, that means that's not typically what it's going to be drawing.
No.
So you need to do it with the average current draw. B, divide the battery ampere hour rating by the average current draw of the equipment. That'll tell you how long you can run the equipment off that battery. About, yes.
Because the efficiency thing's going to come into play there too.
Well, it is, but the average current draw of the equipment, the efficiency is already figured into that.
Yeah, but the battery, if you have a 12 amp battery, you don't ever really get 12 amps out of it. You might get
12
10.
ampere hours.
Yeah.
Yeah. Yep. I mean, well,
But it's gets you pretty close.
yeah. And if it's not a new battery,
Yeah, don't get one from the Hamfest and try to do it. A used one.
err on the safe side. Leave yourself a little extra room in there. But the answer is B, I'm saying.
That's the only right answer on there that's right.
I agree with you. What function is performed with a transceiver and a digital mode hotspot? A, communication using digital voice or data systems via the internet.
B, FT8 digital communications via AFSK.
C, RIDI encoding and decoding without a computer.
Or D, high-speed digital communications for meteor scatter. What function is performed with a transceiver and a digital mode hotspot? But we're not doing any meteor scatter with it, so you can go ahead and take D right off the list.
Okay.
RIDI encoding and decoding without a computer? No. While that actually might be possible if somebody actually got creative with it, that's not the answer. FT8 digital communications via AFSK, that's not a hotspot function either. A, communication using digital voice or data systems via the internet. Yeah, that's going to be your ticket right there. I'm going with A, alpha.
Alpha. That's what the chat room is saying. And we're not talking about a Wi-Fi hotspot here either. We're talking about a digital mode hotspot.
Yeah.
Yeah.
So you do D star, wherever it is on this side.
Yeah.
Or DMR,
Or,
a lot of different ones.
yeah.
Yaesu System Fusion.
Yep.
This what is it, M17?
Yep.
Oh, tons of them. P25.
Yep. But all those are basically just little devices that receive and transmit and take the audio in and out, stream it over the internet to another radio somewhere.
Yep.
on the
I've
World
done
Wide
quite
Web.
a number of segments on digital hotspots on AmateurLogic.
Yeah.
Pretty fun little devices to me.
Yeah.
Where should the negative power return of a mobile transceiver be connected to in a vehicle? A, at the 12-volt battery chassis ground.
B, at the antenna mount.
C, to any metal part of the vehicle.
D, through the transceiver's mounting bracket. Where should the negative power return of a mobile transceiver be connected in a vehicle? A, at the 12-volt battery chassis ground. I'll say that's the right answer, but let's look at the others. B, at the antenna mount. No, that would be a horrible place to do it. C, to any metal part of the vehicle. Where that would get the transmitter or transceiver working, but it is not really the correct place to connect your negative power lead, because then you're dealing with all the loss you've got between the battery and the chassis. Remember we were talking earlier about the resistance in a wire?
Mm-hmm.
Your vehicle's not a good wire.
Technically, it should work, but it's not the thing to do.
Through the transceiver's mounting bracket, where, if the transceiver's mounting bracket was connected to metal on the vehicle.
Yeah, if you were driving a 1970.
Yeah, with a metal dashboard.
Yeah.
Yeah. You would probably light up the light on your radio, but that's not the right place to connect it. It's at the 12-volt battery chassis ground. That's what they're saying in the chat room. Except Francis is saying, what if the car has a positive ground?
Ooh.
Is there even such a thing anymore?
I don't know of any. It might be.
No
I have
modern
no idea.
ones. What if the car has a 6-volt battery?
Like 18-wheelers have a whole bunch of 6-volt batteries.
They got 24-volt systems in there, don't they?
Yeah, but they use multiple batteries.
Yeah. Yeah.
At least they did. The last ones I had anything to do with did.
Yeah. Some old cars did have positive ground, so, and I can't remember what it was, but it seemed like we had a vehicle one time that had a positive ground. I don't remember what it was, though. It was a way, way long time ago. We got one final question tonight. What is an electronic keyer? A, a device with switching antennas from transmit to receive.
B, a device for voice-activated switching from receive to transmit.
C, a device that assists in manual sending of Morse code.
Or D, an interlock to prevent unauthorized use of a radio. It's not D. Let's just start back at the top. It's not D, though. I'm sure of that. It's not an interlock to prevent unauthorized use of a radio. A, device for switching antenna from transmit to receive. Electronic keyer. No, it's not going to be A either. B, a device for voice-activated switching from receive to transmit. Or C, a device that assists in manual sending of Morse code. Got to be C, a device that assists in manual sending of Morse code.
That's what they're saying in the chat room. I'm saying that too.
Because
Yep.
wow, interesting.
Yep. So I'm not sure why this question would appear on the technician exam, since, I mean, you can use Morse code as a technician, and there probably are a few people who do, but it would probably be kind of unusual. And that is all the questions for tonight.
That's all you have to say about that?
Pretty much. Unless you want to add something.
No. It's pretty much sums it up. Those are my thoughts for the evening.
Yep. Eddie said a paddle, and there are paddles to send CW with.
Mm-hmm.
You push one way, that's a dit or a dot. You push the other way, That's a die.
Yeah,
or
I think
dash.
if you hold it in, it does it multiple times.
Yeah. And that would be an example of electronic keyer for manual sending.
Mm.
You wouldn't have to work as hard.
Well,
But I
that
guess
sounds right up my alley.
until you got good at it, it might be easy to stutter. I don't know. I really haven't tried to use one.
Yeah, Morse code just not my thing,
Yeah.
man. I really wish I did know it, but I just never really taken the time to try to learn it. I think it'd be
Haven't
interesting to know it.
Well, Francis is saying right here it's what got him a lot of QSOs on field day. And I think, yeah, we probably could have made a lot more contacts during field day
Oh yeah,
if we were doing Morse. Tommy, how do you like my shirt here?
that's a darn nice shirt, man. I
You
like it a
think?
lot. Where could I get one like that?
Well, there's one place in particular. You can't get one exactly like this.
I bet you could get one pretty close.
You can
Though.
get one very close. This one was custom made by Mr. and Mrs. VE3MIC, our friend Mike.
They did a fine job on them.
It's exactly like the Ham College t-shirts,
Oh,
except it's got these two guys here hanging out.
okay.
But if you needed to get one for yourself, wanted to support the show,
Or just look cool.
or just look cool at the next Ham Fest or any event you go to, I probably wouldn't wear it to church, but you could.
Oh yeah, that's where all the cool people go. To shop.spreadshirt.com/AmateurLogic. You can get cups, caps, jackets, hoodies. Probably don't really need a jacket or hoodie right now, but that day's coming. T-shirts, all kinds of stuff. I think there's some polo type shirts in there.
Yep.
There's tons of things in there.
You can get AmateurLogic or Ham College swag right there.
Yes, sir.
Shop.spreadshirt.com/AmateurLogic. What if you wanted to know what was going on throughout the month rather than waiting for an episode of Ham College? If you just wanted to chat with some like-minded individuals who were hams or maybe not.
If you're into the social media thing, you can go to Facebook. We got a cool Facebook group. Facebook.com/groups/Ham College.
Or
/AmateurLogic.
Mhm.
Probably
You-
more activity in the AmateurLogic one.
you can follow us at Ham College on X or probably still Twitter. I think they resolved to the same place.
Yeah, we also have groups.io/G/AmateurLogic. So if you're not into the social media thing, it's more like a mail list. So if you just want to get the posts about when we're going to be going live, things like that, that's a great place to go for that.
Yeah, the only thing that gets posted there is when we're going to do a live stream or when a new episode has been posted that you can download. And that's pretty much all that gets on there, so you won't get spammed. You non-hams or people looking to become hams, if you don't know, Field Day is an annual activity. It's one weekend in July every year where lots and lots of ham radio
It's actually in
operators.
June, though.
June? Yeah, I think you're right.
I am.
Every year,
Every year. Near the end of June.
near the end of June. And amateur radio operators all over the United States and Canada. I don't know about Mexico, probably Mexico too. Get on the air, make contacts with each other. It's sort of like a contest, but it's not a contest.
It's as close to a contest as you can get without having a contest.
Yeah. And you actually do keep score of how many contacts you make, but there's no awards or, or anything like that. But it just helps you get on the air, exercise setting up your equipment. You get more points if you're not operating from home. If you take your gear out, set it up somewhere. And there's different scoring depending on if you're using utility power or emergency power, batteries, solar power. There's several different things that can change the scoring that you'll get. So it's a fun activity. We do it practically every year.
We've done it pretty well every
Yep.
year except for when it rained.
Yeah,
And then sometimes we've done it then too.
Yeah.
Over here.
that's true. And actually, we're going to have video of that coming up on Friday, July 18th on Amateur Logic.
I can hardly wait to see what we did.
Me too. And I was there. Yeah, we had a few things a little bit different this year.
Yeah, pretty much.
Had a good time.
But that wasn't different. It's always a good time.
It's always a good time. Probably the worst time that we had this past time is when I had an argument and that wasp hit me right here.
Yeah.
And I didn't see it coming.
He sucker punched you.
He sucker punched me. It hurt. But hey, I'm still here. Any final thoughts before we get out of here tonight?
No, just join us at on the 18th for the AmateurLogic. Check out the field day footage. And so AmateurLogic's always a good time too, just like Ham College.
Yep.
Also, if you haven't sent your entry in, get your entry in for the next month's drawing for the ICOM swag.
Yep.
Ham College at AmateurLogic.TV.
That's it. And Francis also said, I learned something new every year I do field days since 1997.
Yeah.
I'm going to say we do too, and we learned
Sometimes it's a
something.
not to do thing.
Yes. We learned something very important this year. I don't know if he'll reveal it or not, but maybe.
Oh.
We'll see. I'll do some arm twisting.
I'll come clean, but it don't matter.
Yeah. Well, you
I'll-
tune
yeah.
in on the 18th. You can find there's something you do not want to get wrong, or it will hamper your communications. And you won't really know why.
Yeah, it'll increase your frustration level.
It will do that, but it'll also give you stuff to talk about.
Yeah, look, we don't usually have a shortage of that.
Yep. Yeah, next Amateur Logic, Friday, July 18th. So that's all I got to say right now. By the way, we do have an IC 7760, brand new ICOM radio sitting over here, and the new PW2 amplifier from ICOM. And Ray, we were trying to schedule him in here to come and shoot some video on that. He hadn't been here yet. We actually took it out and used it at field day this year.
Pretty sweet machine too, man.
Yeah, very sweet. He had to postpone his trip. Sad note here, we'll mention some of you, I'm sure, will know Roger from R&L Electronics, very popular amateur radio dealer, became a silent key this past Saturday. So Ray is going to be going to, I believe it's Cincinnati.
Yeah.
For funeral services, so we've had to postpone shooting a video on that rig and amplifier, but we'll be doing something.
Probably in a few weeks or a month or so.
Yeah.
Maybe.
So,
Anyway, that's coming. Just
yeah.
look for that.
7-3.
So, everybody, good night.
So that's down to either A, which would have 4 amps, or C, which would have 12 amps. I just happen to know.
Wait.
Huh?
What are you looking at? You said A, which you have. Well, A does have 4 amps, but it has 24 volts.
I guess I'm not really
And
looking
C
at
has
it.
12 amps, but it has 24 volts too.
Yeah. Sorry.
I'm like, is something wrong with my contacts? Did I have them upside down?
Okay.
I'm sorry.
She's laughing at me. I would too.
I was looking at that. Like, am I looking at that wrong?
Okay. Sorry. Yeah, it's going to be a long night, Tom. I just happened. Yeah, it's going to be a very long night.